Hello everyone! For our geometry problem today, I've picked a proof that uses the equidistance theorem. I always get a lot of questions on how do you use the equidistance theorem. So I'm going to show that to you. I've drawn a separate little triangle in the corner down here to just show exactly how equidistance is used in a simpler setting. So in this bottom right triangle, if I could get that congruent to that, and this congruent to this, then we would have the equidistance theorem, because it would mean that AD is perpendicular to EC. Now here's how I visualize this. The two congruent markings that are identical, these two, they both are touching D. Okay, think of like tracing those congruent markings back to the common point that they touch, and that's letter D. Now look at the other pair of congruent markings, this one and this one. They both trace back to touch point A. They both have point A in common. And the circled letters, A and D, those are the letters that form the perpendicular bisector. So AD is perpendicular to EC in this situation. So now if we look back up at our current problem that we're trying to do and compare it to that, here's D and here's A. So here's our goal. We want to have ED congruent to DC, just like in my triangle down here. And we would love to have AE congruent to AC. Because if we had those two pairs of sides congruent in this more complicated looking triangle, then we would have our final proof statement that AD is perpendicular to CE. So this is our plan that we're going to execute. Let's copy down the givens first of all. So one given is that AB is congruent to AF. And let's mark that on the picture. That's just here and here. Number two, BD is congruent to DF. That is here and here. And the third given is angle 1 is congruent to angle 2. So they give us that. Okay, I'm just going to write the word want by these arrows just to remind us what we want in the end, but we don't have it yet. And those are the things that we want congruent. Okay, now let's look at the things that we do have congruent. Those sides that are congruent, right here, congruent to here, this congruent to this, those are definitely leading us towards these two triangles, AFD and ABD. And we definitely can get those congruent very easily. I'm just going to unhighlight that so we don't have too much going on. We can definitely get those two triangles congruent because this is reflexive. So I'm going to include step 4, that AD is congruent to AD by the reflexive property. And I forgot to write given for the first 3 things, but that's what it would say. So I'll just put given, given, given. All right, but now we have enough to say that triangle AFD is congruent to triangle ABD. by SSS. And then if your teacher has you do this, that's the parts that were listed in step 1, step 2, and step 4. That's sometimes an optional thing that teachers make you write. You'll know what it means if you're already doing that in your class. Now, those two triangles, usually following the triangle congruences, you want to have a CPCTC step. So I'm looking at this, and if I say that this angle is congruent to this angle, that will get us one step closer, because right after that then I'll be able to say that this angle is congruent to this angle, which will give us our much needed information about these two triangles, that one and that one. All right, so the first step though is to say that angle AFD is congruent to angle ABD, and that's because of CPCTC, which almost always will be the next step right after something like SSS. Now, step 7, I was already pointing out how that will automatically get us that angle EFD is congruent to angle CBD. And it's going to be because of subtraction. Now, some of your teachers might make you write that AFE is congruent to ABC because all straight angles are congruent. Let's just do that just in case your teachers make you. Angle AFE is congruent to angle ABC, and that's because all straight angles are congruent. And then that leads us to that subtraction step that I said. Angle EFD is congruent to angle CBD. And that's because of subtraction. And the way that helps us is now the highlighted triangles have ASA, proving them congruent. So in step 9, I can right away turn over to those triangles. Triangle EFD is congruent to triangle CBD because of angle side angle, ASA. Those steps include the given back in number 3, the subtraction step that I just listed, which was number 8, and FD congruent to BD, that was way back in number 2. So steps 3, 2, and 8 give us the ASA. Okay, now the reason that is so helpful to have those smaller triangles congruent is now we have another CPCTC step where we can say that ED is congruent to CD by CPCTC. And if you look, that was one of our wants. We wanted those congruent. So we're right on the right track. The other want was that we wanted AE congruent to AC. Well, we've almost got that too because of the addition property. But the first thing I would need to say is that FE is congruent to BC, which is also by CPCTC of those two small triangles. So FE is congruent to BC, again by CPCTC, which then causes the whole thing AE to be congruent to AC because of addition property. And then, so that's what we wanted. This, I'll put like 4 marks right there and right there. And now that we have everything that we planned ahead of time that we wanted to have congruent, we have our prove statement, which was saying AD is perpendicular to CE. And that is because of the equidistance theorem. So I'm going to just write equidistance theorem. Some of your teachers might make you write out what the equidistance theorem says, and that's fine too. You would just have to write it out. It says, if 2 points are each equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of the segment. Now that's a lot to write. Some teachers do make you put that all in the reason column, but some just let you write equidistance theorem like I did. Whichever is fine. And that is it.